Okay, so critical regions again, but looking in the other tail. So we have a maths pun. So in a particular city, a lobster card is used as a method of payment on trains. The company claims 1 in 1,000 cards would be rejected by the card reader. And the station manager thinks the company is understating the proportion of cards, and we're looking to find a critical region at the 5% significance level. So X is geometric 0.001, and the null is at P equals 0.001, and the alternative is the station manager's belief that actually it's a bit more than that. He's finding, he thinks more than 1 in 1,000 are rejected. Define your parameter, so where P is the probability a card is rejected. Right, so if P is bigger than 0.001, you're going to get the card being rejected more quickly. And so we need to think about the probability of X being less than or equal to C of being less than the significance level of 5%. So you're basically saying if P is 0.001, then the probability I get a result this extreme, so i.e. you get your rejection quite soon on, we want that probability to be less than 5%, in which case you say actually that was too soon, I'm going to accept the alternative. Any problems with that logic you need to tell me, and I'll try and reword it as best as I can. So the probability X is less than or equal to C. This is 1 minus the probability X is bigger than C. And if X is bigger than C, then you will have had C times where it's been accepted. And then the rejection will come after that. So this is 1 minus the probability of it being accepted to the power of C. And then we need that to be less than 0.05. And then similarly to last time, we're going to be using logarithms. So I'm going to add this to the right hand side, take 0.05 away from the left hand side, and I'm going to write it around the other way. I'll let you think about that if you need to. So we need 0.999 to the power of C to be bigger than 0.95. Then you can take logs of both sides, and I'm going to pull down this power as well. You can take natural logarithms here if you wanted to. So logs of both sides, power comes down, then I divide. This is going to come out as being negative, so you need to reverse the sign. So C is less than log 0.95 over log 0.999. And popping that into a calculator, so log 0.95 over log 0.999, you get a C less than 51.267. C is an integer, so C is less than or equal to 51. So the critical region is x less than or equal to 51. So the station manager does a test and he records the number of people that pass through until a card is rejected. If the number of people until the first card is rejected, and including that one, is less than or equal to 51, then you'd say that's too unlikely to happen by chance, and so you accept the alternative that P is bigger than 0.001. And then to find the actual significance level, I want to find the probability that x is less than or equal to 51. So that's similar to what I had on a minute ago, but that's 1 minus the probability x is bigger than 51. The probability x is bigger than 51 is 0.999 to the power of 51. So that's that bit there. So it would have gone through okay for the first 51 trials, and so the failure will happen after the 51st trial. We're not really worried where. So that gives you 0.0497 for your actual significance level.